The chart then, we're going to compare our original function, which is y equals x squared minus 4, with our reciprocal function, which is 1 over x squared minus 4. So our domain for our original function, which is a quadratic, is all reals. And our range, if you recall, is related to our vertex. And because we have a parabola that opens up and our vertex is at 0, negative 4, we have a range which is y is greater than and equal to negative 4. Our x-intercepts for our original function are at 2 and negative 2. And we have a y-intercept which is at negative 4, and it just happens to be our vertex point. Okay, on our graph, there's only two values that x cannot be. Okay, and if you take a look at the green part of the graph, we have all these negative x values along here. And notice the graph goes up along the vertical asymptote, which is where x is negative 2. And then once you go on the other side of the vertical asymptote at negative 2, we have all these x values that are between negative 2 and 2. And then you hop over to the other side of the vertical asymptote where x equals 2, and you have all these x values that go off to the right. So the only two numbers or two values that the domain cannot have in a reciprocal function, or this one in particular, is at x equals 2 and x equals negative 2. So we just say that it's all real numbers except that x can't be 2 and x can't be negative 2. Now for our range, there are two parts to the graph. There's the part that's above the x-axis, and there's the part that's below the x-axis. If you take a look at the part above the x-axis, our y values go from positive infinity all the way down, and they approach 0 but never actually touch where y is equal to 0. Okay, and remember, y equals 0 is on the x-axis. So for both parts at the top, we have infinite values for y in the positive direction. We just will never get a value for y equals 0 on the bottom part. So we say that above the x-axis, y is greater than 0. Okay, and if you take a look at the bottom or below the x-axis, we have what looks like it could be a parabola opening down, and we can see that its maximum point is at 0 and negative 4. So that means that below the x-axis, y is less than or equal to negative 1 over 4. All right, do we have any x-intercepts on our reciprocal function? And there are none. There's no part on this graph where the line will cross over the x-axis. And so we have no x-intercepts. We have vertical asymptotes though, one at x equals 2 and one at x equals negative 2. Okay, take a look at your y-intercept. It happens to be the relative maximum point of our reciprocal function, which is at 0 and negative 4. So we have a y-intercept at negative 1 over 4, and note it's the reciprocal of our y-intercept for y equals x squared. All right, and we have a horizontal asymptote which is at y equals 0. All right, now let's take a look at what happens around our vertical asymptotes. I'm going to just draw one of them here, and we'll take a look at the one where x equals 2. We want to substitute a value in for x, which is just a little bit smaller than 2, so 1.99999. That means we're approaching the vertical asymptote from the left. So we are approaching x equals 2 from the left. Okay, numbers to the left of this are the numbers which are just slightly less than 2. And let's see what the value for y is. So we will substitute that x value in, and we will get 1.99999 squared minus 4 in the denominator. and we find that we get a rather large number, negative 25,000, which means that our y values are approaching negative infinity. Okay, so it goes to negative infinity. Okay, so if we go back up to the graph, and we are approaching from the left of x equals 2, and note that the graph is going down sharply, okay, and it will continue that off to infinity. Okay, so describe the behavior of the reciprocal graph as x gets closer but still less than 2. It goes down to negative infinity. Okay, now let's approach our vertical asymptote on the right. Okay, we're going to pick a value which is just slightly bigger than 2. So we're going to pick 2.0001 and find out what y is. So this means we are on the right of x equals 2. Okay, so let's substitute that in. We're going to get y equals 1 over, and then 2.0001 squared minus 4, and we get 2,499.9. All right, well, that's a rather large number, so it looks like y is going, or it goes to positive infinity. Okay, so let's go back to the graph. We are on the left of our vertical asymptote, and you can see that the graph is going rapidly up to positive infinity. Okay. All right, so describe the reciprocal graph of x equals. Describe the reciprocal graph if x is 2 and y so. All right, well, because this is our vertical asymptote, it means that at this point it's undefined. Okay, and so the graph never actually touches x equals 2. So what does happen? Well, the y values on one part of the graph go up to positive infinity, and the y values on the other part of graph approach 0. Okay, and I can show you that. We'll pick a x value which is rather large. Put 100 in. And I find that y is equal to 0.0001, which is a really small number, and you'll find that the bigger numbers that you plug in for x, the smaller this number is going to get, and so we're going to get closer and closer to 0. And we can see that on the graph too. If we take a look, our graph will go closer and closer and closer to the x-axis where y equals 0, but it will never touch. Okay, so that ends this short video.